Alright, so we've already talked about how to handle surds with just simplifying. So again, we want to look for the perfect square that's going to come out of that, and then rewrite our surd. Okay, so I want to skip that and instead do a few more examples where we're expanding out brackets and then simplifying if we've got two terms in our denominator. So if we look here, we've got 3 minus root 7 squared. So that means I've got 3 minus root 7 times 3 minus root 7. And again, remember we're going to do first outside, inside last. So my first term is going to be 9. Outside is going to be 3 root 7, minus root 7. So minus 3 root 7. Inside is going to be minus 3 root 7. And the last is going to be minus root 7 times minus root 7, so plus root 49, okay, which simplifies to 7, okay. From there, I want to rewrite my expression so that I've simplified it so that I've got my whole numbers added together and my surds added together. So I've got 9 plus 7 gives me 16 plus, or actually, I don't want plus, I want minus because I've got two negatives. So just rub that out. Okay, so minus, and then I've got one group of 3 root 7 and another group of 3 root 7, so I'm going to get 6 groups of 3 root 7, so minus 6 root 7. Thinking about combining surds, think about it like you were combining x's and y's. So as long as the surd is the same, so I've got root 7 in both of these cases, think of it as I'm combining x's. So if I had minus 3x and minus 3x, I would have minus 6x. So same thing. Now if I had something like a root 2 in here, that would be like a y. Okay, so I can't simplify that, but what I can do is keep those separate. Alright? If we look at this one, this is actually going to lead quite nicely into our discussion on rationalizing if we have two terms in the bottom, or sorry, in the denominator. So remember our difference of two squares. So we have something like x squared minus 25. And I want you to keep in mind how we factorize something like that. So it's going to look like x plus 5 times x minus 5. And remember that cancels out that x term in the middle. And we're going to see something similar happen here. So my first term is going to give me the 49. When I look here, I've got 7 times 2 gives me 14. So plus 14. I'm doing very well here. Sorry. Plus 14. 14 root 2. Okay, and then I've got minus 14 root 2. Okay, and then last I've got 2 root 2 times minus 2 root 2. So I'm going to multiply the 2 and the 2, which gives me minus 4. And then I've got root 2 times root 2 gives me 2, so 4 times 2. Okay. So if I simplify that, that gives me 49 minus 8. So 49 minus 8 gives me 41. And then I've got plus 14 root 2 minus 14 root 2. So these cancel out to 0, and I'm left with just 41. So when we have a difference of two squares, that is going to allow us to cancel out our square root term, our surd term, without having to do anything super complicated. So let's do 1 minus root 5 and 2 minus root 5. So I want to get rid of that root 5 term. So if I have 2 minus root 5, to cancel that out, I want 2 plus root 5. And that's because I want to have those root 5s cancel out in the end. Okay, and again, whatever I do to the top, I have to do to the whatever I do to the bottom, I have to do to the top. Okay, so that makes it 2 plus root 5 on the top as well. So again, we're going to do first outside, inside last. 1 times 2 gives me 2, minus 2 root 5, plus root 5, and then minus root 5 times plus root 5 gives me minus 5. Okay, that's my numerator. My denominator, 2 times 2 gives me 4, minus 2 root 5 on the inside, plus 2 root 5 on the outside, and then minus root 5 times plus root 5 gives me minus 5. Okay, so then when I simplify that, again, I want to simplify my whole numbers first, so 2 minus 5 gives me minus 3. Okay, and then minus 2 root 5 plus root 5 leaves me with minus root 5. Okay, and then on the denominator we have 4 minus 5 gives us minus 1. Minus root 5 plus 2 root 5 gives us, minus 2 root 5 plus 2 root 5 gives us 0, so those two cancel. So I'm left with this. What I can do is I can factor out that negative, and I get 3 plus root 5. Okay, and that's just from dividing everything by minus 1. Okay, so minus 3 divided by minus 1 gives me a plus 3. Minus root 5 divided by minus 1 gives me a plus root 5. Okay, and that's my final answer. Alright, okay, so another example of that is 2 plus root 2. So again, keeping in mind that difference of two squares, I want to do 2 minus root 2. Okay, so I'm going to have on my denominator 2 minus root 2, and on my numerator 2 minus root 2, because again, remember you want to keep the same as the top, keep the same for the top and the bottom. Okay, so again, I'm going to do first outside, inside, last. So I will start with my numerator because it's easier. It's just going to stay the same, so I'm just multiplying by 1. Okay, and on the bottom, first term gives me 4. Outside gives me minus 2 root 2. Inside gives me plus 2 root 2. And my last term, so plus root 2 minus root 2 gives me minus 2. Okay? Or minus root 4, which simplifies to minus 2. So I end up with 2 minus root 2 on the top. And on the bottom, 4 minus 2 gives me 2. And that cancels. Okay, so that's going to be my final answer. Now, I can't simplify that because if I were to do 2 over 2, I would have to do a factor out of 2. What I can do is break up this fraction so that I've got 2 over 2 minus root 2 over 2, and that leaves me with 1 minus root 2 over 2. Okay? Alright, so I hope that helped with rationalizing the denominator with surds, especially for those more complicated ones. Okay?